Hello students, today we are going to study design parameters. The first design parameter is standard axle load. Now the maximum standard axle load is equals to 8170 kg, which will be equals to 8.2 tons. Now single wheel load will be equals to, it needs to be divided by 2, so it will be equals to 4085 kg or 4.1 tons. Legal axle load, that is dual wheel assembly, it will be equals to 10.2 tons. Now stress at any depth, we have to find the stress at depth Z, that is here. Now it can be found by the formula, that is P into 1 minus Z cube upon A square plus Z square to the power 3 by 2, where P is contact pressure, Z is depth and A is radius of contact area. Now actual shape of contact area is elliptical, but Indian Road Congress consider as circular for calculation purpose, that is like this. Now contact pressure will be equals to load divided by contact area. If contact area is equals to pi a square, then contact pressure will be equals to P divided by pi a square. Now the next factor is rigidity factor. Rigidity factor is equals to contact pressure divided by tire pressure. Generally, contact pressure equals to tire pressure equals to 7 kg per centimeter square. Now at low tire pressure, the contact pressure will be greater than tire pressure and walls of the tire remains under compression, which is shown here. Similarly, at high tire pressure is greater than contact pressure, so the wall of the tire remains under tension, which is shown here. Now if rigidity factor will be equals to 1, then contact pressure and tire pressure both will be equals to 7 kg per centimeter square. And if rigidity factor will be less than 1, then contact pressure will be less than 7 kg per centimeter square and tire pressure should be greater than 7 kg per centimeter square. Now if rigidity factor is greater than 1, then contact pressure will be greater than 7 kg per centimeter square and tire pressure will be less than 7 kg per centimeter square. Now the next theorem is the mclead theorem. It states that load is inversely proportional to number of load repetition, that is P is inversely proportional to N, which is shown here, where P is the load in kg and N is the number of load repetition. So P1 N1 is equals to P2 N2. Now the next topic is the equivalent single wheel load. It is defined as the load on single tire which will cause an equivalent magnitude of parameter such as stress, strain and deflection at the given location resulting from multiple wheel loads at the same location. Now this is the center to center distance between two tires and this is the load applied by the tire. This is the clearance distance between the two tires. Now this distance is known as 2s, which is shown here. Now observation of equivalent single wheel load. Up to depth d by 2, equivalent single wheel load will be equals to P, which is shown in the diagram. Beyond depth 2s, equivalent single wheel load will be equals to 2P. Between d by 2 to 2s, equivalent single wheel load variation is logarithmic variation. Now here P is the load on single wheel, D is the clear distance between inner wall of tire, S is the center to center distance between wheel. Now we have to find the load at any depth Z. So at any depth log Z between log 10 d by 2 and 2s, we can determine the load by this formula, that is log 2p minus log p upon log 2s minus log d by 2 will be equals to log 2p minus log pz upon log 2s minus log z. That is all about the design parameters. Thank you students.